window exactly as you have shown.
Yeah, yeah. Okay. Okay, we'll discuss that. There are few more. Yeah, we'll solve more on Leetcode. Yeah.
Okay.
Okay. And you have solved this. Have you solved all the test cases
The
first?
negative, yeah, the negative. I'm actually not exactly sure. I tried to use a Q, but the question I have is why cannot I use this method on negative numbers?
Okay. No, I am asking the Leetcode question which you have just shown. Have you solved
Yeah.
that?
Yes, I have. I have. Give me a second. Let me open it up. Seem to have not.
Okay, let's discuss that later. Okay, so for
Okay.
negative number, can you tell me what we have discussed? Like, I also check what was that question.
Um. So the negative number. This is the one. Here.
Given an array of all positives, find the maximum sum.
So
Yeah,
I mean, I don't know. First of all, I'm not sure why the output is 5. Because if it's a size of k, that's k of 3. This one is the biggest one, right? So it should be 8.
yeah, that will be 8 8. Yeah, output. I have given a random example, so yeah, just update that.
Okay. Okay. Whoa, it's so slow.
Yeah, that will be 8.
Sorry, it, I'm in the wrong file. I still cannot edit.
You can edit it now. Just reload that.
It still says file is view only.
Give me a minute. Sharing. Anyone can edit. State. So now try again. Yeah, let's reload once. No, I think this is not that file. The first one. Which one? I think you open the same file again.
Okay. Did you send it in the mess? Oh, okay, in the mess.
Yeah,
I see another mess.
yeah, yeah. The last problem was you have to find the maximum sum for a given slides size of slide, right? So, subarray size means here you can say that slide of size. Okay, so your question was for why we cannot use if there are both negative and positive elements. The
Yeah.
sliding window,
Why?
I discussed most of the problems. Basically, it's if you are doing monotonically increasing or decreasing. So let me annotate one. Can you close that here from the right top side? That one.
Okay.
Yeah. Okay. Yeah. So if you let's say this is a graph. Simply,
Yep.
okay. So let's say this is a graph, and this graph is increasing, or let's say I have another graph, that graph is decreasing. So decreasing or increasing, in that case sliding window will you can apply. Why sliding
Okay.
window? Because you can, as means you can decide like which, let's say you have lots of numbers, array of numbers, positive
Yep.
integer numbers. So sliding window, when you are doing so, you have some assumption. You have to assume something like, if I move the next slide, I will. So let's say the array is all positive. Take that scenario. So you
Yep.
first take a slide of that array, means the sub array of that array, and you decide, means you check the sum. Let's say you are summing that all the sub arrays elements. So you got some summation of that survey. For the next slide, you are sliding. Let's say you are sliding, means moving your slide. So you got another summation for the
Okay.
next slide. Now, if all the numbers are positive, take that scenario. If all the numbers are positive, you can say that
It will
yeah,
it will increase.
it will increase. So let's say, yeah, it will always increase for the next slide. But let's say in between you got a negative number, so that means your sum may be same or maybe decreased, right? So you cannot miss conclude some solution from that from for
Okay.
that um
But why, like, if I'm just moving my window like this,
hmm, hmm,
if I'm just like, for example, here I check
hmm.
what the sum is, and then here I check what the sum is again, why would this having a
Yeah,
negative? It would. Why
I
though? Like,
I think for this question I told you that for this question you can use. For other
oh,
problems,
okay,
yeah.
okay,
So let's take another problem today, then we can you can understand that better. So
okay.
write the problem, and then we can again jump to this question and we'll discuss. Okay. Given a subarray, given an array of both positive and negative integers,
Yep.
you have to find the subarray given an array. Okay, just wait. Let me, yeah, copy that one. So the problem is basically your longest subarray with some given sum. Okay, so let's say you have a array given with you, and that array can contains both positive and negative. Okay, now you have to give in some. So one sum is also given, and now you have to find the longest subarray from that given array uh, for that given sum. So you have to find for let's say this is the array one, and you have a sum. This is the target sum basically. You have to find. It has only positive elements. Just take another example. Uh, let's take combine both positive and negative. Or let's say this one. So target sum, let's say I have five only. Okay.
Yep.
So yeah. So you have to find the length of that subarray, longest subarray having the sum equal to the uh, given just to the given sum basically. Okay. So here I think for this example it's two, right? So yeah. Now here it has already mentioned that it has both positive and negative, right?
Okay.
Hmm? Now tell
Yeah.
me, how do you approach this question? Let's start with brute force. Then we will apply sliding if it will work or not. We'll check. Then we will move to the optimized one. Okay.
Okay. So
Hmm.
the brute force would just be, I'll just loop over it,
Hmm.
and like
Yeah, brute force
I'll do.
same. So I
Okay.
think yeah, yeah, try yeah, right, that brute force. So I think last day I also mentioned that most of the brute force techniques uses you have to find all possible subarrays for that given array, and then you have to compare and check if the given sum is there or not, right? Yeah.
Yeah.
Now you can write that.
The brute force.
Yeah, brute force first, then we jump to the solid.
Okay. So I'll um I'll just say I'll just loop over this array. And then I'll keep a current sum. Then and then I'll loop over like from where like 10, 5.
Hmm.
So then I'll add to this current sum nums. Oh, it's quite nums. And if this current sum equal to the target sum, I'm going to like have a counter or
Like you have to find the length of that every subarray and you have to compare basically, right?
okay. So maybe I can have a
Counter, yeah.
counter
Yeah.
and if this is equal then I'll have another one called max counter. I'll set it to 0 first.
Yeah.
Then I'll just do this. Is that right? Count counter.
uh Take a good name, like a variable name you can change, right? We are finding the length, so you can take this as a
Okay.
length. Yeah,
Lame.
meaningful name, right? So yeah, so what you have done, you are using the outer loop and inner loop you are finding for okay, let's do for dry run with this code. So what we are doing, our main intention is to find every possible subarray for a given starting point. So let's say 10 is our first starting point, so I point to 10. 10 means your zeroth index, and from there you are finding for, let's take 0 10 and minus 5, so you are taking this subarray, you are summing
Yes,
that
yes.
up, and then you are comparing, that is the target sum. Yeah, that's the target sum. You find the length. Length is count. Okay, so how do you find the length? Length will be j minus I plus 1, right? Count.
Okay, yeah.
Yeah,
I
count.
was thinking more
Yeah,
like count as I add every single one.
for the next one it will be become 3. So let's say you are starting from, let's say, for minus, this one also have a sum of 5, right? So how can you say that the count is 2 here? So we cannot use that count here basically, right?
Okay.
So what we can do, so just remember most of the problems we do, like how to find the size of any server. So size of a server is basically the
J
last,
minus
yeah,
I
the last
plus
index,
1.
yeah, last position of an index, and the starting position. So j is the last position any subarray,
Yep.
minus the starting of that starting position, and then you have to add plus 1. Basically, why add plus 1, tell me?
Because it's exclusive when the length of in Python. So
Not
it's actually missing
not
one
it's
number.
not specific to Python, remember. So plus 1 is basically index are starting from 0, right?
Yep.
But how many, what is the length of this array?
6.
6. But 6, right? So what is the last position of this array? Last index?
But it's 5. 5.
5. 5 minus 0, it's starting from
Yep.
0, and this is 5. So 5 minus 0 plus 1, that gives you the correct answer, right? 6. So this is not specific to Python, this is for every uh, programming language, but the logic is
Okay.
for the programming language where the array starts from the index 0. That's the logic, right? So yeah,
Okay.
so that's the basic brute force approach. And time complexity is nested loops. You are finding all possible subarrays, and that is quadratic, so n square time complexity, number of
Yep.
arrays. N square, n
Yeah.
into n plus 1. So another thing, do you know how to find the time complexity? It's not related to this problem. So
I
how?
I usually just
Hmm,
I don't know if it's right, but I usually just look at the loops, like how many
not
loops I have, if it's nested, and if it like O of n does it go over all the elements in the array.
this is not always correct, but yeah, because some of the problems we will discuss that logic will fail most of the time. Nested loop does not mean that it's always gives you n square time, because lots of problems are there in a lead code also, you will get confused. Okay,
Okay.
so now how to find this? I'm just giving you an example. So how many times the first loop executes? It's n times. For every n times, how many times this loop executes? So let's say I is pointed to 0. Let's say I is at 10. So you are taking 10 minus 1, then you are taking 10 minus 5, sorry, minus 5 minus 2, right? Then you are
Yep.
taking 10 minus 5 minus 2 and then 7. Then you are taking 10 minus 5, 2, 7 and 1. So basically how many times? So for every n you are taking all possible 1 plus 2 plus 3 plus 4, right? So if it is running n times, how many times the inner loop executes? You have to think about that.
From how many times?
The inner loop executes. So for I1, let's say the outer loop is at one time is executing the first iteration. So for first iteration, how many times it executes n times, right? So n minus 1 you can say better. It's n minus 1 or n, right? I starts from 0. So n. So for the next iteration, I starts from 1. 1, right?
One.
I am
Yeah,
taking the
it starts
counter,
from
not the
one.
index. Yeah, 1. So it 1 into n minus 1. So from here to here, all possible subarrays: minus 5, minus 2, minus 5, minus 2, 7. Then from 3, it's executing uh, n minus 2 times into n minus 2. So if you sum up, it's basically n, you can, it's a kind of, you can say n plus n minus 1 plus, like that you can do, and it's give you n square time complexity. It's a theory based question, but yeah, I'm telling you.
Okay.
Now try to implement the sliding window. Is it will pass the test cases? Just think about that and let me know the problem that we have solved last day. The same,
Okay. Yeah.
apply the same
This
logic.
one, if I apply the same one,
Hmm.
then first of all, there's no size given.
Yeah, no
So
size given. Yeah,
yeah, no
you have
size
to
given.
find the
And
size here.
sorry.
Yeah, means you have to find the size here, right? The length, that's the size.
Yeah, exactly. And I know that every positive number I add, or the negative number I add, it's going to like get smaller. And if I add a positive number, it's going to get bigger. So it's different from the last one.
Yeah, so let's say yeah, sometimes it's increasing, sometimes it's decreasing, right? So
Decreasing, yeah.
yeah, so let's say you're increasing, suddenly you decrease, and then you are again increasing, and then let's say you are decreased. uh, so the curve is kind of increasing decreasing, right? So
Yeah, yeah.
it's not linear, or it's not like the graph is not the same, like it's monotonic, neither monotonically increasing or decreasing. So that's why uh, here we cannot conclude that we have to, if we move the slide, right? So in the sliding window, what we do, we either slide right, from let's say we are sliding our slide, I mean moving our slides, right? We are taking another subarray. So you cannot conclude that for the next slide it gives me that target sum. Basically, there may be some number for the next slide which gives you means there is positive and negative, right? So you cannot
Yeah, yeah.
conclude that if you move the slide it gives you the perfect result. So let's take another scenario, like